Hello there and welcome. I'm so glad you're here. Maybe you had a long day, or maybe the night just felt like it needed something to fill it. Something warm and slow and far away from whatever is on your mind. Either way, this is a good place to be. There is nothing you need to do right now. Nothing to decide. Nothing to finish. Nothing to carry into tomorrow that cannot wait until morning. Just rest here. Let your body grow heavy. Let your thoughts soften at the edges. Because tonight, we are going somewhere ancient. Somewhere that has been burning long before any of us arrived and will keep burning long after. We are going to the world's volcanoes. Not to the danger or the disaster, but to the deep, slow fire that built the ground beneath your feet. We will move gently through 100 quiet truths, from the first eruptions that shaped this planet to the volcanoes humming silently beneath the ocean floor right now. Some of what you hear may feel familiar. Some of it may settle into you like warmth. And if these slow, calm explorations help you rest, consider liking and subscribing. It helps others find their way here too, one sleepy soul at a time. Now, close your eyes if you'd like. Let your breathing slow, and let's begin. There are more than 1,500 potentially active volcanoes on Earth. Not all of them are erupting right now. Most are quiet, resting between cycles, holding their heat inside, waiting. But they are there, on every continent, beneath every ocean, part of the living system of a planet that has never fully cooled. About 50 volcanoes erupt somewhere on Earth every year. That sounds like a lot, but spread across the entire planet, it becomes something else. A steady, quiet rhythm, a release of pressure happening somewhere always, the way a sleeping body shifts and settles through the night. The Earth is never entirely still. Most volcanic activity on this planet happens underwater, far from any coastline, far from any human eye. The ocean floor is the most volcanically active place on Earth. Where tectonic plates pull apart at mid-ocean ridges, magma rises constantly through the gap and hardens into new rock, fresh basalt laid down in the dark. The ocean floor is being made right now in silence. The ground beneath nearly all of the ocean's floor is volcanic rock. Basalt, formed from ancient lava flows, covers the vast majority of Earth's seafloor. It is younger than the continents, constantly renewed by the spreading ridges, and it forms the foundation of the world's oceans. Everything the ocean rests upon was once molten. Volcanoes created Earth's early atmosphere. In the planet's first billion years, volcanic eruptions released enormous quantities of water vapor, carbon dioxide, nitrogen, and other gases from the interior of the Earth. These gases accumulated, formed clouds, and eventually rained down, filling the earliest oceans. The air you breathe tonight, the water in your body, the ground beneath your bed, all of it traces back, in some part, to volcanic outgassing from a young and restless Earth. The word volcano comes from Vulcan, the Roman god of fire and the forge. The Romans believed that the island of Volcano near Sicily was the chimney of his workshop. When it erupted, they understood it as the god at work, hammering, creating. The smoke rising into the sky was the breath of something deep and intentional. They were not so wrong. Something deep is at work, even now. Lava can reach temperatures of over 1,200 degrees Celsius. At that heat, rock flows like slow water. It moves in sheets, in rivers, in slow creeping tongues across the landscape. Most lava moves slowly enough that a person can walk away from it comfortably. It is not fast. It does not chase. It simply advances, relentless, patient, consuming everything in its path with a kind of unhurried certainty. Lava comes in two main forms, and even their names feel like the thing they describe. Pahoho, smooth, ropey, folded into gentle curves as it cools on the surface while still moving beneath. And rough, clinkery, broken, the kind that tears at shoes and sounds like cracking glass underfoot. Both come from the same magma. The difference is how fast the lava moves and how much gas it holds. The same fire, expressed in two entirely different textures. The color of lava tells you its temperature: bright white or pale yellow. The hottest, above 1200 degrees. Vivid orange, flowing freely. Still intensely hot. Deep red, slowing at the edges. Cooler, beginning to crust. Even the dimmest glow of lava at its edges is still around 700 degrees Celsius. What looks like cooling rock is still many times hotter than anything we encounter in ordinary life. Even its darkness holds heat. Shield volcanoes have broad, gently sloping sides that look almost nothing like the steep peaks most people picture. They form from thin, fluid lava that flows far before cooling, building wide, low mountains over thousands of eruptions. Mauna Loa in Hawaii is the largest shield volcano on Earth. From its base on the ocean floor to its summit, it rises over 9 kilometers, making it taller than Everest when measured from its true base. From the surface of the ocean, it looks modest. Most of its immensity is hidden, and beneath the ocean, Mauna Kea, the neighboring peak on Hawaii's Big Island, rises to a height of over 10 kilometers from its base on the seafloor. The tallest mountain on Earth, if you measure from the bottom of the ocean to the top. It is covered in snow at its summit and ringed by coral reefs at its base. A single volcanic mountain spanning nearly every climate zone Earth has to offer. Hawaii itself exists because of a hot spot. Not a plate boundary, not a ridge or a trench. Just a plume of extraordinarily hot material rising from deep in the mantle, burning through the overlying plate like a blowtorch held beneath a sheet of metal. As the Pacific Plate moves slowly northwest over the hot spot, new islands form in sequence. The oldest Hawaiian islands to the northwest are worn down, eroded, sinking slowly. The Big Island, youngest and largest, sits over the hot spot now, still growing. Southeast of it, a new seamount, Loihai, has been building for thousands of years beneath the surface. It may breach the ocean in tens of thousands of years. A new island, already in progress, already rising. Iceland sits on two things simultaneously: the Mid-Atlantic Ridge and a volcanic hotspot. This combination makes it one of the most volcanically active places on Earth. The island is being pulled apart at the ridge, new land forming in the gap, and the hotspot beneath it adds extra heat, extra eruptions, extra lava. Iceland is literally being built as it is being torn open. It exists because of the fire beneath it. Without those eruptions, the island would have sunk beneath the sea long ago. Stratovolcanoes are the ones most people picture. Tall, steep, symmetrical, dramatic. Mount Fuji, Mount Rainier, Mount St. Helens. They are built from alternating layers of ash and lava, each eruption adding to the structure. They tend to be more explosive than shield volcanoes because their magma is thicker and holds more gas. The pressure builds slowly over years or decades, then releases. They are beautiful and they are powerful and they are patient. Mount Fuji has not erupted since 1707, but it is still considered active. More than 300,000 people live within 10 kilometers of its summit. Millions more live in the greater region that would be affected by a major eruption. And yet, those same millions consider the mountain sacred. They climb it, they paint it, they build their lives in its shadow and look up at it with something that is not fear exactly, something more complicated. A relationship between people and the fire beneath the earth that goes back as long as humans have lived near mountains. In Japanese tradition, Fuji-san is the dwelling of a goddess. In Hawaiian tradition, Pele is the goddess of volcanoes herself. She lives in the Kilauea caldera and is both creator and destroyer. She forms new land and she consumes what is old. Ancient cultures across the world developed similar understandings, not wrong ones. Volcanoes do create and destroy. They do give life and take it. They have always demanded a certain kind of respect, one that required neither fear alone nor reverence alone, but something of both. Kilauea on Hawaii's Big Island has been erupting almost continuously since 1983. More than 40 years of nearly unbroken volcanic activity. Lava has flowed into the ocean, hardening into new coastline. Entire neighborhoods were consumed in the 2018 eruption, and yet new land was added to the island. The coastline grew. Fresh black rock, cooling into the sea, becoming ground. The loss and the creation happened at the same time, side by side, as they always have near a volcano. The youngest surface on Earth is fresh lava, sometimes only minutes old. When lava hardens in the ocean, it forms shapes called pillow basalts, rounded bulges of rock that cool so quickly on the outside that they hold their shape. These pillows pile up along mid-ocean ridges by the millions, forming the foundation of the seafloor. The newest rock on Earth is being made right now, underwater, in the dark, adding millimeters to the ocean floor that will last for millions of years. Surtsey is an island off the coast of Iceland that did not exist in 1962. In November 1963, an underwater volcano broke the surface and erupted for nearly 4 years. By the end, a new island, about 2.5 square kilometers, had formed in the North Atlantic. Scientists designated it a nature reserve immediately and have watched it ever since. Within years, birds landed. Seeds arrived on the wind. Mosses and grasses took hold. Life colonized an island that had not existed when most living people were born. Volcanoes create some of the most fertile soil on Earth. The minerals in volcanic rock, potassium, phosphorus, calcium, break down over time into soil that is extraordinarily rich. Java in Indonesia is one of the most densely populated islands on Earth, and much of that population is sustained by the volcanic soil that makes its land so productive. The slopes of Vesuvius near Naples have been farmed for 2,000 years. People knew the risk. They stayed for the soil. The fire gave them their food. Pompeii was a city of around 11,000 people when Vesuvius erupted in 79 AD. Within about 18 hours, it was buried under several meters of ash and pumice. The city was sealed, preserved. When archaeologists began excavating it nearly 1,700 years later, they found bread still in the ovens, frescoes on the walls, graffiti scratched into stone, the remains of people who had no warning, or not enough, preserved in the positions they fell. Pompeii is not just a disaster. It is a window, an accidental archive of daily life held perfectly in ash. Vesuvius is still active. It last erupted in 1944. Today, more than 3 million people live in what is called the red zone, the area most at risk from a major eruption. Evacuation plans exist. The mountain is monitored continuously, and people live there, as they have always lived there, growing tomatoes in the volcanic soil, looking up occasionally at the mountain, and going on with their days. Volcanic ash is not like fireplace ash, It is made of tiny fragments of pulverized rock and glass, microscopic, jagged, and abrasive. It can travel thousands of kilometers from the eruption site on high-altitude winds. It damages aircraft engines, clogs machinery, and can collapse roofs under its weight. The 2010 eruption of Eyjafjallajökull in Iceland grounded tens of thousands of flights across Europe for weeks. The ash cloud spread slowly, silently across the continent. A mountain few had heard of became the center of the world for a brief, quiet, disruptive moment. The 1815 eruption of Mount Tambora in Indonesia was the largest volcanic eruption in recorded human history. The explosion was heard more than 2,000 kilometers away. The eruption column rose 50 kilometers into the atmosphere, and in the months that followed, the ash and sulfur dioxide it released spread around the globe, blocking enough sunlight to lower global temperatures. 1816 became known as the year without a summer. Snow fell in New England in June. Crops failed across Europe and North America. Famine followed. One mountain, erupting on one island in one ocean, changed the weather of the entire world for a year. Volcanoes can cool the planet. When an eruption sends sulfur dioxide into the stratosphere, it combines with water to form tiny droplets of sulfuric acid that reflect sunlight back into space. The effect is temporary, lasting 1 to 3 years, but measurable. The 1991 eruption of Mount Pinatubo in the Philippines released enough material to lower global average temperatures by about half a degree Celsius for 2 years. Small in absolute terms, large in effect. The planet breathed differently for a while because of one mountain. Volcanic lightning, sometimes called a dirty thunderstorm, occurs during explosive eruptions. As ash and rock are hurled into the atmosphere, particles collide and build up electrical charge. The result is lightning within the eruption column itself. Bolts appear to arc through the ash cloud, threading through the rising dark material, glowing against it. It looks like something from a dream. Fire and lightning together, the atmosphere responding to the earth with its own electricity. Pyroclastic flows are the most dangerous volcanic phenomenon. Not lava. Lava is slow. Pyroclastic flows are clouds of superheated gas, ash, and rock fragments that race down the slopes of a volcano at speeds of up to 700 kilometers per hour at temperatures that can exceed 800 degrees Celsius. They hug the ground. They travel faster than any vehicle. They are nearly impossible to survive in their path. When Vesuvius buried Pompeii, it was not just ash that killed. It was a pyroclastic surge that hit the city almost without warning. Hot and fast and final. And yet, after the pyroclastic flows cool and the ash settles and the years begin to pass, life returns. This has always been true. Pioneer plants, mosses, ferns, certain grasses, are among the first to colonize new lava fields and ash-covered landscapes. They break down the rock, add organic matter, build soil from nothing. Insects follow, birds follow. Within decades, a disturbed volcanic landscape can be alive with species again. Within centuries, it can be forest. The destruction creates conditions for something new. It always has. Obsidian is volcanic glass. When lava cools very rapidly, especially on contact with water or air, it solidifies before crystals can form, producing a smooth, jet-black glass with edges sharp enough to cut. Ancient peoples across the world made tools and weapons from obsidian. Knives, arrowheads, scrapers. Its edges are sharper than surgical steel. It was traded across thousands of kilometers in ancient times. A volcanic byproduct carried from hand to hand across continents, shaped into something useful, valued precisely because of its origin in fire. Pumice floats on water. It is the only rock that does. Pumice forms when frothy, gas-rich lava cools so quickly that the bubbles are frozen in place, leaving a rock full of tiny air pockets, light enough to float. After major submarine eruptions, vast rafts of pumice can cover hundreds of square kilometers of ocean surface. Ships have sailed through them, and these floating islands of rock carry microorganisms, barnacles, and small creatures across ocean basins. Pumice is a volcanic ferry, carrying life to new places on a slow, floating journey. Diamonds are brought to the surface by volcanoes. Deep beneath the earth, under extraordinary heat and pressure, carbon crystallizes into diamond. The only way those diamonds reach the surface is through a rare and violent type of volcanic eruption called a kimberlite pipe, a narrow channel of magma that rises from depths of over 150 kilometers at extraordinary speed, carrying fragments of deep mantle rock with it. These eruptions are ancient. Most kimberlites are billions of years old. The diamonds inside them are older still. A stone on a finger, formed in the deep earth, carried up by fire, billions of years in the making. Gold and silver deposits often exist near ancient volcanic systems. Hydrothermal fluids, hot water carrying dissolved metals through cracks in the rock, can deposit precious metals as they cool. Over millions of years, these deposits accumulate. Many of the world's great gold and silver mines sit in regions of ancient volcanic activity. The ore in those mines was placed there by heat and water, deep in the earth, in geological time. The wealth beneath the ground has volcanic origins. Magma chambers sit miles beneath the surface of active volcanoes. These are not hollow caverns of molten rock. They are more like sponges, zones of partially melted rock under enormous pressure. They can be miles wide and miles deep. They are fed from below and release upward. The pressure inside them builds slowly, over years or decades, until something shifts. A crack opens, a pathway forms, and the magma begins to move. The time between a chamber filling and an eruption can be measured in centuries. Some eruptions are preceded by swarms of small earthquakes. As magma moves through rock, it pushes and fractures the material around it, creating thousands of tiny seismic events. Volcanologists watch these patterns carefully. A cluster of small earthquakes beneath a volcano can mean magma is on the move. It can be a sign of what is coming, days, weeks, or sometimes years away. The mountain speaks in tremors before it speaks in fire. Animals sometimes sense volcanic unrest before instruments detect it. There are accounts of animals behaving strangely in the hours or days before eruptions. Birds falling silent, insects disappearing, livestock refusing to stay near the slopes. Whether they are detecting infrasound, ground vibrations, or changes in gas emissions is not fully understood. But the pattern has been observed enough times to be taken seriously. The world around a volcano is sensitive in ways we are still learning to read. There are volcanoes beneath the ice of Antarctica. Hidden under kilometers of ice sheet, several volcanic systems exist on the Antarctic continent. Some are dormant. Others produce enough heat to melt the base of the ice above them, creating subglacial lakes. Liquid water in total darkness, sealed beneath miles of ice. Whether life exists in those lakes is one of the quieter questions in science. The conditions are extreme, but extreme conditions have never stopped life before. Geysers are surface expressions of volcanic heat. Where water seeps down into hot rock and becomes superheated under pressure, it can erupt periodically through a narrow channel as a column of boiling water and steam. Yellowstone's Old Faithful has been erupting approximately every 90 minutes for as long as it has been observed. A rhythm of pressure and release so consistent it became named for its reliability. In the basin around it, thousands of hot springs, fumaroles, and mud pots bubble and hiss, the landscape breathing through the thin skin of rock above the heat below. Yellowstone sits over a supervolcano. The magma chamber beneath it is vast, roughly 80 kilometers long and 20 kilometers wide. The last 3 major eruptions occurred 2.1 million, 1.3 million, and 640,000 years ago. The interval between them is not regular enough to be predictable. The system is monitored constantly, and the land above it, the geysers, the bison grazing on thermal meadows, the rivers running through steam, has no knowledge of what lies beneath. It simply lives there, above the heat, in a kind of ordinary peace. The Toba eruption, approximately 74,000 years ago in what is now Sumatra, was one of the largest volcanic events in the last 2.5 million years. Some researchers have suggested it may have caused a volcanic winter so severe that the human population was dramatically reduced, perhaps to just a few thousand individuals. The evidence is debated, but if it happened, almost every human being alive today is descended from that small group of survivors. Every person, every language, every civilization, from those few thousand people who endured the winter of the fire. Not all volcanic eruptions are explosive. Most of the volcanic activity on Earth is quiet. Lava welling up gently through ocean floor cracks, thin flows moving slowly across flat ground, degassing, the release of volcanic gases, happening continuously through fumaroles and vents without any dramatic discharge. The fiery violence of famous eruptions is real but rare. Most of the time, the Earth releases its heat gently, steadily, without announcement. Volcanic lakes can be extraordinarily acidic. The crater lakes that form in caldera volcanoes are sometimes among the most acidic natural water bodies on Earth, some with pH levels approaching 0, close to battery acid. They are often beautiful, vivid green or turquoise from dissolved minerals, and they are almost entirely lifeless. Ijen volcano in Indonesia has a turquoise crater lake that steams gently and glows with the pale color of diluted sulfuric acid. Miners descend into the crater at night to collect pure sulfur from its vents, carrying it up in baskets on their backs. The volcano gives, and it asks much in return. Lake Nyos in Cameroon sits in a volcanic crater and holds an unusual danger. Beneath the lake, volcanic activity slowly releases carbon dioxide, which dissolves in the water and accumulates under pressure at depth. In 1986, something disturbed the lake. A small landslide, a tremor, something. And the bottom water turned over, releasing an enormous cloud of carbon dioxide. The gas, heavier than air, rolled silently down the valley surrounding the lake. Nearly 1,800 people and thousands of cattle were killed overnight. No fire, no explosion, no warning. Just the slow accumulation of a volcanic gas released all at once. Venus has thousands of volcanoes and may still be active. Its surface, mapped by radar from orbiting spacecraft, shows vast plains of lava, enormous shield volcanoes, and volcanic features found nowhere on Earth. Some scientists believe the planet's surface was completely reshaped by volcanic activity roughly 500 million years ago. A global volcanic catastrophe that buried everything beneath fresh lava. And recent radar observations have shown what may be active volcanic vents, their shapes changing between measurements taken years apart. Our neighboring planet, similar in size to Earth, may be as volcanically alive as we are. Io, the innermost large moon of Jupiter, is the most volcanically active body in the solar system. Its surface is covered in sulfur and sulfur dioxide frost in shades of yellow, orange, red, and white. Hundreds of active volcanoes erupt continuously. Lava lakes ripple and churn. Plumes of sulfur rise hundreds of kilometers into space. Io is volcanically active not because of internal heat from radioactive decay, as Earth is, but because of tidal heating. Jupiter's immense gravity constantly flexes and squeezes the moon as it orbits, generating friction and heat. The moon is being heated by gravity, and it releases that heat and fire. Cryovolcanoes, ice volcanoes, exist on some of the cold moons of the outer solar system. On Enceladus, a moon of Saturn, geysers of water vapor and ice shoot from cracks near the South Pole, rising hundreds of kilometers into space. The water comes from a liquid ocean beneath the ice shell, heated by tidal forces. These plumes contain organic molecules and traces of the chemicals associated with life. Enceladus is one of the places in the solar system that scientists most want to study for signs of biology, and it advertises itself with jets of water erupting quietly into space. The largest known volcano in the solar system is Olympus Mons on Mars. It rises about 22 kilometers above the surrounding plain, nearly 3 times the height of Everest. Its base is 600 kilometers across. It is so large that if you stood at its center, the edges would be below the horizon. It formed over billions of years of volcanic activity in a region called the Tharsis Plateau, where Mars's internal heat concentrated into a handful of enormous shield volcanoes. Mars no longer appears to be volcanically active. The fire inside it has dimmed, but it left its record in rock, enormous and enduring. Lava tubes form when the outer crust of a lava flow cools and hardens while the liquid lava inside drains away, leaving a hollow tunnel. These tubes can stretch for many kilometers and are found on Earth, the Moon, and Mars. On Earth, lava tube caves are used as natural refrigerators in some cultures, holding a constant cool temperature year-round. On the Moon and Mars, lava tubes may be large enough to contain entire cities, and their rock ceilings would provide protection from radiation. Future human habitats in the solar system may be built inside the ancient tunnels that volcanoes left behind. Volcanic rock covers the surface of the Moon entirely. Unlike Earth, the Moon is no longer geologically active. Its interior has cooled, but billions of years ago, its surface was covered in vast lava flows. The dark patches visible on the lunar surface with the naked eye, the Mar, or seas, are ancient volcanic plains, basalt lava that flooded enormous craters and cooled flat. When the Apollo astronauts walked on the Moon, they walked on volcanic rock. The ground beneath their boots was made by fire, billions of years before they arrived. The rock that makes up much of the continents is granite, formed not from lava flows, but from magma that cooled slowly underground, deep within the crust, never erupting. These intrusive igneous rocks crystallize over millions of years in what are called plutons. As the rock above them erodes away over geological time, the granite is exposed at the surface. The exposed granite mountains of Yosemite, the Scottish Highlands, the Brazilian Highlands, all of them began as magma chambers. The fire that created them never reached the surface. It cooled in the dark, slowly, patiently, and became stone. Tephra is the collective name for all material ejected by a volcano. Ash, cinders, lapilli, and volcanic bombs. Volcanic bombs are large fragments of lava hurled from a vent and partially cooled in flight, arriving on the ground as solid or semi-solid rock. They can be meters across. They land with a thud, steaming, sometimes still glowing at their core, and then they cool, and they stay. Permanent records of a moment of violent expulsion, now simply part of the landscape, indistinguishable from any other rock to someone who doesn't know what they're looking at. Some volcanic materials glow long after the eruption ends. Certain types of lava retain heat in their interiors for months or even years after the surface is crusted over. Steam continues to rise from cooling flows long after they stop moving. Deep inside old lava fields, temperatures remain high. The fire is slow to leave. The landscape looks cold and still, gray and broken, and beneath it, heat lingers quietly. The earth holds warmth the way a stone holds the warmth of a summer afternoon long after the sun has set. Volcanologists study eruptions at close range. This requires extraordinary care, protective gear, constant awareness, practiced routes of escape. But some volcanologists have stood at the rim of active craters and looked in, have watched lava lakes circulating below, incandescent and slow, have felt the heat on their faces and the sulfur burning in their eyes. They do this because there is no other way to understand what is happening. The data instruments gather is essential, but there are things you only know by standing there, by feeling the ground vibrate beneath your feet and the heat rising toward you like a wall. Ancient Roman engineers used volcanic material called pozzolana, a fine ash from the Pozzuoli region near Naples, in their concrete. Mixed with lime and seawater, it produces a concrete that hardens underwater and becomes stronger with age. Roman harbor structures built with this material have survived 2,000 years of immersion in seawater. Modern scientists have studied it and found that the seawater actually causes mineral growth within the concrete over time, reinforcing it. The most durable construction material of the ancient world was volcanic. The Romans built with fire. The entire Italian peninsula is shaped by volcanism. The Apennine Mountains contain ancient volcanic rock. The Phlegrean fields near Naples, a vast caldera system, occasionally inflate and deflate as magma and fluids move beneath the surface. The ground literally rises and falls over years in a process called bradyseism. Buildings tilt, coastlines shift, and people have lived there for millennia through every cycle of the ground's slow breathing, building and rebuilding as needed. Volcanic hydrothermal systems heat water naturally. In Iceland, geothermal energy heats homes, powers greenhouses, and fills the famous Blue Lagoon, a warm, mineral-rich pool of water that emerged from a geothermal power plant's outflow and became something beautiful by accident. In New Zealand, the Maori have used geothermal pools and steam vents for cooking and bathing for centuries. In Japan, hot springs, onsen, are fed by volcanic heat and are woven into the culture of rest and renewal. The volcano gives warmth. It has always given warmth to those who learn to live near it carefully. The heat inside the earth comes from two sources, partly from the decay of radioactive elements, uranium, thorium, potassium, that release energy slowly as they break down over billions of years, and partly from the original heat of Earth's formation. The energy of countless collisions as material came together to form the planet, heat that has been slowly escaping ever since. 4.5 billion years later, the planet is still releasing that original warmth. The Earth's interior is still cooling from its birth. The volcanoes are part of that process, heat moving outward, slowly, continuously. inevitably. Without volcanic activity, Earth's interior would cool more quickly, and the planet's magnetic field would weaken. Earth's magnetic field is generated by the motion of liquid iron in the outer core, driven by heat rising from below. That heat keeps the core fluid and the dynamo running. The field deflects solar wind and cosmic radiation, protecting the surface and the atmosphere. Life as we know it depends on that field, and the heat that sustains it is the same heat that drives volcanoes. The fire beneath the ground is not separate from the conditions that allow life. It is part of what makes life possible. Some volcanic eruptions send material all the way into the stratosphere. Most weather happens in the troposphere, the lowest layer of the atmosphere. But large eruptions punch through it into the stratosphere above, where there is no rain to wash particles out, no weather to disperse them. Material injected there can spread around the globe and remain for years. It changes the color of sunsets. It scatters light. After major eruptions, sunsets worldwide become more vivid. Reds and oranges more saturated, lasting longer after the sun goes below the horizon. The sky is painted by the volcano months after the eruption on the other side of the world. The Deccan Traps are one of the largest volcanic features on Earth, a vast plateau of layered basalt covering much of western India. They were formed by an enormous episode of flood volcanism that began around 66 million years ago, roughly coinciding with the mass extinction that ended the dinosaurs. For hundreds of thousands of years, lava erupted continuously from fissures in the earth, covering hundreds of thousands of square kilometers and basalt kilometers thick. The gases released may have contributed to the deterioration of the global climate at a time when it was already under stress from other causes. The dinosaurs lived and died on a planet that has always been geologically restless. Flood basalts are among the most impressive volcanic features in Earth's history. Unlike the cone-shaped eruptions most people picture, flood basalt events involve vast quantities of lava welling up from long fissures in the earth and spreading across flat terrain in sheets. They can cover areas as large as continents. The Columbia River basalts in the Pacific Northwest cover more than 160,000 square kilometers, with individual lava flows reaching hundreds of kilometers in length. They erupted between 17 and 6 million years ago. The landscape you see in eastern Washington and Oregon, those flat, dark, layered cliffs, is a frozen record of one of the most sustained volcanic episodes in North American history. Volcanoes and the carbon cycle are deeply connected. Carbon dioxide released by volcanic eruptions is absorbed by rain, which then chemically weathers rocks, carrying the carbon into rivers and eventually the ocean, where it is incorporated into shells and sediment and eventually subducted back into the mantle. This cycle operates over millions of years and has helped regulate Earth's climate over geological time. Without volcanic emissions, the cycle would slow. Without weathering and subduction, carbon would accumulate. The volcano is not just a disruptor of climate. It is part of the system that has kept the climate habitable over billions of years. Volcanic islands are among the youngest places on Earth. The rock beneath your feet, almost anywhere, has been there for millions or hundreds of millions of years. But on a young volcanic island, the ground may be only thousands of years old, or less. Some lava fields in Hawaii are so recent they have not yet developed soil. The rock is bare and black and sharp, and yet life is already beginning. Lichens attach to the surface. Wind carries seeds. The slow process of turning fresh rock into living landscape has already started. What is new is always becoming something else. As you rest here tonight, somewhere on the planet, lava is flowing. It may be moving beneath the ocean in a slow, quiet extrusion along a ridge. It may be spilling down a slope on the big island toward the sea. It may be welling up gently in a rift zone in Iceland or Ethiopia. The Earth has not stopped. Its interior has not cooled. The fire that built the ground you're lying on, the minerals in the rock, the soil in the fields, the mountains on the horizon, is still working, still moving, still shaping the surface of the world. And now, in this quiet moment, let that settle in. You are resting on volcanic rock. Directly or a few layers removed, the ground beneath this building, beneath this city, beneath the soil of this region, is made from material that was once hot, that was once fluid, that rose from deep inside the earth and cooled into something solid enough to stand on. The stone is ancient, but it was not always stone. It was once fire. The iron in your blood was forged in a star. The calcium in your bones, the oxygen you are breathing right now, all of it came from somewhere that was hot. Something exploded, or collapsed, or burned, and the material scattered, and eventually, across billions of years and unimaginable distances, it found its way into you. You are not separate from the fire. You are made of what the fire left behind. So let the ground hold you. Not just the mattress, not just the floor, but the rock beneath it. The ancient, cooled, patient rock that spent millions of years rising and cooling and becoming solid, just so that eventually, tonight, you could lie on top of it and rest. The earth has been preparing this ground for a long time. It is steady, it is old, and it is not going anywhere. Let your breathing slow to something like the rhythm of the earth itself. Not fast, not anxious, just the long, slow exhale of a planet that has been breathing since before life existed. In and out, deep and unhurried. The fire far below, the cool air above, and you, between them, perfectly warm, perfectly still, perfectly safe. You can rest now. The ground will hold you. It always has. If you happen to